Our journey begins on North America, 55 million years ago. During the last thermal maximum, when the North American continent was covered in forests. The Hyracotherium, or Eohippus, was a small dog-like creature with an arched back that lived during the Eocene epoch, and among some of the oldest fossils from the Perissodactyla order to be discovered. It had 4 toes on its front legs and 3 toes on its hind legs. Each toe was capped with a hoof, increasing its speed as it traversed across soft forest floors. In fact, DNA and fossil evidence suggest that the Hyracotherium and another closely related perissodactyl during this epoch, Cambatherium thuesi, gave an insight to the earliest common ancestors of horses, tapirs, and rhinos. As Earth's climate cooled during the late Eocene, the vast forests began to dry into grasslands. And about 38 million years ago, Mesohippus appeared, a descendant of Hyracotherium. A few million years later, a similar species, Meohippus, had evolved. Both these descendants of Hyracotherium lived together at one point, and were considerably larger, with longer legs, 3 toes instead of 4, and teeth better adapted to eating abrasive grasses. Parahippus lived in the later Miocene epoch. This ancestor of the modern horse adapted one very important characteristic: the ability of its teeth to withstand against the wear and tear that eating grasses causes by having high-crowned teeth with enamel extending beyond the gum line. Such animals are known as hypsodonts. Species of Merychippus, appearing later, only grew in size. They exhibited a middle toe that was much larger, and carried most of the individual's weight. While this allowed for increasing adaptations to running, and other anatomical changes occurred to support the body, there was still an added stress on the longer legs and toes of Merychippus due to its body mass. This proves that evolution doesn't always improve an organism's way of life. Dinohippus appeared about 10 million years ago, after several years of stress on the legs. As one of the closest known relatives of modern-day horses, zebras, and donkeys, which make up the Equus genus. Some members of the Dinohippus genus had 3 toes, but some evolved into monodactyls with only 1 large toe that reduced the stress of the horse's weight. Species of Equus were discovered in the fossil record about 5 million years ago, and with their appearance came migration. Traces of these species have been found from the Great Plains of North America to South America, and later across the Bering Strait land bridge into Europe. Then, at the end of the Pleistocene, the end of the last ice age resulted in an extinction event in the Americas, causing many large mammals to go extinct. Horses that had crossed the land bridge continued to survive and evolve in Europe, Asia, and Africa. For a long time, modern horses were thought to be descended from horses domesticated by the Botai people in Kazakhstan. However, recently discovered DNA evidence shows that Przewalski horses, thought to be the last of all wild horses, are actually just escaped Botai horses, and these 2 breeds appear on a different branch of the horse family tree than many other breeds. So, the common ancestors of the modern horse still remains unknown. Despite this gap in the fossil record, the evolution of modern horses isn't disproved, as conditions for preserving animal remains, especially as fossils, are quite rare. This gap simply means that connection between modern horses and their common ancestors just hasn't been discovered yet. Nevertheless, thousands of years later, when explorers set sail for the New World, horses returned to their place of origin. North America, and selective breeding continued to play a role in the evolution of horses. Not everyone is lucky enough to see evolution occur right in front of them, like the Grants with the Galapagos finches, but through fossils and DNA, we can see evidence of how organisms have changed over time. And from a dog-like creature to majestic stallions, horses are no exception to evolution.